This is Euclid Book 10, proposition number 87. And moving right along here, we're going to find the third apotome. Let a rational straight line A be set out. There it is. Let three numbers E, B, C, and CD. Well, where's E? There's E right there. That's a number. Where's BC? That's a number there. And where is CD? Well, that's a number there. And they're going to be set out, and none of them have to one another the ratio which a square number has to a square number. But let CB have to BD. Okay, so let this have to this the ratio which a square number has to a square number. Let it be contrived that as E is to BC, as this is to this whole length here, so is the square on A. Well, here's A here, and this is the square on A. Has to the square on FG. Okay, well, here's line FG, and here's its square here. Okay, so let me state this again. As this line is to this line, okay, as this is to this, so is this is to that. And as BC is to CD, as this is to this, so is the square on FG to the square on GH. So is this is to this. This is by Euclid Book 10, proposition number 6, Porism. Since then, as E is to BC, as this is to this here, so is the square on A to the square on FG. So is this to that. Therefore, the square on A is commensurable with the square on FG. These are commensurable. This is by Euclid Book 10, proposition number 6. The square on A is rational. This is rational. Therefore, the square on FG is also rational. That's rational. Therefore, the length of FG is rational. That's rational. And since E has not to BC, this does not have to this, the ratio which a square number has to a square number, therefore neither has the square on A to the square on FG, the ratio which a square number has to a square number. Therefore the length of A is incommensurable with the length of FG. This is incommensurable with that. That's by Euclid Book 10, proposition number 9. Again, since as BC is to CD, as this is to this, so is the square on FG to GH, so as this is to that. Therefore, the square on FG is commensurable with the square on GH. These two areas are commensurable. This is by Euclid Book 10, proposition number 6. But the square on FG is rational. This is rational, so this is rational here too. Therefore, the length of GH here is rational. And since BC has not to CD, as this does not have to this, the ratio which a square number has to a square number. Therefore, neither has the square on FG to the square on GH. These here do not have a ratio which a square number has to a square number. Therefore, the length of FG, this right here, is incommensurable in length with GH. Right here. This is by Euclid Book 10, proposition number 9. And the length of FG and the length of GH are both rational. Therefore, FG and GH are rational straight lines commensurable in square only. Therefore, FH is an apotome. There's your apotome right there. This is by Euclid Book 10, proposition number 73. I say next that it is also a third apotome. For since, as E is to BC, as this is to this, so is A to FG. So is this to that. There's a ratio. And as BC is to CD, this is to this, so is the square on FG to the square on HG. This is to that. Therefore, xi quali, as E is to CD, as this is to this, so is the square on A to the square on GH. So is this is to that. This is by Euclid Book 5, proposition number 22. but E has not to CD. This does not have to this. The ratio which a square number has to a square number. Therefore, neither has the square on A, it's this right here, to the square on GH. This does not have to this. The ratio which a square number has to a square number. Therefore, the length of A is incommensurable with the length of GH. This is incommensurable with that. That's by Euclid Book 10, proposition number 9. Therefore, neither the straight lines FG and GH, neither this nor this, is commensurable in length with the rational straight line A set out. This is not commensurable with that, and this is not commensurable with that. Now, let the square on K be that by which the square on FG is greater than the square on GH. What does that mean? Well, if you add the area of this and this together, you get that. Since then, as BC is to CD, as this is to that, so is the square on FG to the square on GH. So as this is to that. Therefore, convertendo, as BC is to BD, as this is to that, so is the square on FG to the square on K. So as this is to that. But BC has to be BD, the ratio which a square number has to a square number. So this has to this, the ratio which a square number has to a square number. Therefore, the square on FG also has the square on K. This has to this, the square, the ratio which a square number has to a square number. Therefore, the length of FG here is commensurable with this length right here, which is K. This is by Euclid Book 10, proposition number 9. And the square on FG is greater than the square on GH by the square on a straight line commensurable with FG, because we said that if you add these two areas together, you get that. And neither of the straight lines FG and GH, neither this line nor this line, is commensurable in length with the rational straight line set out. Therefore, FH is an apotome, and it's the third apotome. Therefore, the third apotome FH has been found. Wow. Okay. That is enough for tonight. I will tell you more in a future video. Stay tuned.